All right, guys, here's 1.3 limits of rational equations, part 3. This is when the degree is higher on the top than the bottom. And when we were finding horizontal asymptotes, this would be a situation where it does not have a horizontal asymptote. If the degree on top is 1 greater than the bottom, then it would have a slant or oblique asymptote. So how are we going to find this now that we can't use our asymptote techniques from algebra? Here's the book's philosophy on these. Divide everything by the highest power of x. Okay, so anytime you're doing limit as x approaches positive or negative infinity, then you can use this technique. Remember, if this is a numerical value other than infinities, you gotta just plug it in, okay? What's the highest power of x on this guy? X to the fifth. So we're gonna divide every term by x to the fifth and see what happens. As long as we're dividing every term by the same number, it's legal algebraically. And now let's cancel. This cancels with that. One of these cancels with one of those. That's it. Now apply the limit. As this goes to infinity, that goes to 0. That goes to -6. This goes to 0. This goes to 0. And so what do we have? We have 6 and it's negative over 0. So how are we going to do this? We graph it. Okay? So you can graph this and see where this is approaching as x is approaching positive infinity. If you don't want to graph it, then you can use the Smith method. The Smith method is it only behaves like the highest power of x on top, so that's gone. It only behaves if it was a polynomial in its own right on the bottom, it would only behave like the highest power of x. Then one of these x's cancels with one of these x's, and you're left with -6x to the fourth. Throw your positive infinity into the original equation. Positive infinity raised to an even power is positive infinity times -6 means negative infinity. Graph that on your graphing calculator and see if you get the same thing that I did. Again, when the degree on top is greater than the degree on the bottom, we have no horizontal asymptote. So we have to use the Smith method or graph it. The Smith method says this polynomial up here only behaves like the highest power of x. This polynomial down here only behaves like the highest power of x. What happens? One of these x's cancels with one of these x's, and you're left with x squared over 2. Erase and replace it with negative infinity. Negative infinity squared is positive infinity divided by 2. And a huge number divided by by 2 is still a huge number, okay? And some of you might be wondering, well, shoot, when I cancel x's, doesn't that create a situation where I may have an extraneous root or a root that I didn't account for? The answer to that question is sometimes, okay? So we do have to be careful when we start rational equations part 4 and look at values that are trapped under radicals. So let me explain. The original was x to the third, and then this was 2x after we got rid of the highest, only looking at the highest power of x's. If we apply negative infinity to it right now, that would be negative infinity cubed, which is negative, divided by 2 times negative infinity, A negative divided by a negative is a positive. So we don't have to worry about our sign changes on these. It works. The Smith method works every time until we get radicals under them, okay? Why does the Smith method work on problems like this? Well, when I cancel an x with an x up top, I'm canceling two x's, an x on top and an x on the bottom. So a positive divided by a positive is just that, positive. A negative divided by a negative is going to be a positive as well. I hope that makes sense. We will take a look at part 4 coming up here in a minute.